This strange looking 19-inch rack here is actually what I'd call a CRT unit for both analog and microprocessor experimentation. The whole idea is you make it up as you go along. That's why this is unfinished with the holes and there's no knobs on these buttons, and these sockets don't go anywhere. The idea is to build up as you go along and try various experiments. For a long time I've meant to make one of these, but finally I've bitten the bullet and done it. It's taken me about 6 or 9 months maybe to actually go this far, but it actually works. And what's great about it is you can take it out and you can fiddle around with it and you can do stuff. What's the sort of things you can do with it? Well, how about playing around digital storage scope? I mean, obviously very low frequency compared to the expensive ones, but that's quite a bit of fun having a stored digital display. I also rather like the idea of the sort of reinventing the simple video games like Pong. I thought it would be fun driving a spot around the screen and having a paddle on it and you know, scoring it if you can actually hit it back and this sort of thing. And of course from there then you could add sound effects as well, which adds a bit of audio to it. Hence there's some audio inputs or outputs depending what we use these for. And we could always try that. Then of course you can have pattern generator. It's fun playing with patterns sometimes, seeing what the what it looks like, or maybe a text generator. Generating text. This is all using microprocessors, of course, or a scope clock, which seems to be a few of those around now, where you have a clock on the CRT and it tells the time. So you'd have to build a clock circuit, obviously, with your microprocessor. But there you go. So that's the whole idea behind it. In here we have a power supply and we have the CRT unit. There is a microprocessor that goes in the middle, but we'll cover that in our next video. Here we see round the back of the unit. You can see we have a big space here with nothing in it. Essentially there are two portions we can look at. This is just a basic power supply. It's nothing special about that. We have the HT side is on this side of the plate there, and this gives us about plus or minus 350 volts, which is all you need for this tube. This is a very low voltage tube. These DG731s run on a very low HT if you compare them to ordinary tubes. They were deliberately made for low voltage applications. So with 700 volts across it you can have a really nice sharp clear spot on a bright screen. So that's well worth considering. There are a lot of these available at the moment. It's not like some of the more obscure World War II types. This one you can find these. There's a lot of these for sale at the moment. On this side of the board we have a couple of regulators. That's all just for the 5 and 12 volts, and these outputs here are for the microprocessor. The microprocessor board sits quite happily in here. Note there's no connections to half of these bits and pieces, but as I said, this is an ongoing thing. You make it up as you go along. This part now you can question why we've used valves for it. There are in fact 4 valves. There's 1 here and 3 along there. The point is, if we're using high voltages here anyway, what's the point in trying to find high voltage transistors to use to drive it? We may as well just use the valves. I mean, they're easily obtainable. Very simple circuit. There's not a lot to talk about other than that. So that's why we've chosen to use valves for that. Just a brief look at this to see it actually working. We have no inputs in it at all. The microprocessor is not connected. So all we'll have is going to be a single spot on the screen that's just appeared there. This floats around a little bit because nothing's connected to it. We have, that's obviously a Y shift. This is an X shift. I've deliberately kept it out of focus because it doesn't, we don't want to burn a hole in the screen while we're messing around here. So that's the way it goes. That just shows what we can do, and obviously we can put an X and a Y. This is exactly the same as on an oscilloscope. There's in a good oscilloscope, or most oscilloscopes will have an X and a Y. We can turn off the time base and you end up with a thing like this. The whole idea behind this, remember, is to create a whole, self-contained unit, so you don't have to have bits of test equipment hanging on to make it work. So here we go. Let's just push that down there a little bit. If we now just take 2 oscillators, we hope there's one on the other end of this. Yeah, there's one end of it. Now we can focus that up a bit. And we connect up the other oscillator in here. We should end up with a circle. So of course we can centralise that, and you can create all your other different patterns, litigious patterns, just by using different frequencies and things. I mean, you can see how it is. We're able to just mess with it and make it do what we want to do. So that's about all we're going to show for this particular video. Okay, so we'll have a little look now at the circuit diagrams.